Hi, everybody. This is Mr. Folly, and welcome to Podcast 7.1, where we're going to talk about how chemical changes rearrange atoms and bonds. Talk about the total number of atoms does not change in a chemical reaction. The total number of particles can change in a reaction. Two molecules can become one. The signs of chemical change, balancing equations, and coefficients represent particles and moles. Let's hop to it. Chemical changes rearrange atoms and bonds. So, kind of what we did when we first looked at things is we looked at pictures of these things. So, these are atoms, these are really molecules of nitrogen and molecule of hydrogen. And, get back here. And what you'll notice is, you see how my N would be a circle. So, over here I need one circle and I need three hydrogens. And hydrogen would be a box. Okay. Now, these things need to balance. So I'm rearranging this circle bonded to circle, and it's no longer bonded to a circle, it's bonded to three boxes. So now what happened is I have a leftover circle. Now, on this right-hand side, all I can make are NH3. So I have to make another one of these because I have a leftover circle. Okay? So now I need to make sure I have enough H's to do this. I have 1, 2, 3. I have 1, 2, 3, 4, 5, 6. And here I only have 2. So again, the only thing I can add is double boxes. So now my total number of atoms here, I have two N's. I have two N's. I'll write it this way. This way we're going to write it later. N equals 2, right? H equals 6. And over here, the circles, N equals 2, H equals 6 is 6. Okay. The total number of atoms is constant. N is 2, H is 6. Okay. So the number of atoms is constant. Wow. Okay. And we have rearranged the atoms and we've rearranged the bonds. Okay. Originally N was bonded to N, now N is bonded to H. Originally H was bonded to H, now H is bonded to N. The total number of particles can change. Let's do the same thing again. I'll call iron a square, and we'll make chlorine the double ring. Doesn't really matter that much. But here, notice I have one square, and I have three rings. Ring-a-ding-a-ding. Okay? So notice from here, my squares are good, but I don't have enough circles to make this happen. So I need to get 3 of them. It's going to be 10 minutes. I'm sorry. Yes, that'll be great. Did you want to take it now? Okay, that's fine. 4th period works. All right, so now I have 4 of them, and I'd have one left over circle. Okay, so if I see 1, 2, 3, 4, get back here. And I have 1, 2, 3, so I have a leftover circle. So that means I need to add a whole nother one of these. Okay, so now if I need to add a whole nother one of these, I need another iron. Okay, now I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So when I write this as a balanced equation, I would have 2 Fe's, 3 Cl2s, right? 1, 2, 3 Cl2s, and I would have 2 FeCl3s. I didn't balance this one. I should have. This has a coefficient of 1. This has a coefficient of 3. This has 2. See, 1, 2, 3. 1, 2. Okay. On a microscopic level, bonds are breaking and forming. Okay, so notice bonds formed with square to circle and bonds broke with circle to circle. So you need to know that bonds break and form in a chemical reaction. All right, so now signs of chemical change. Heat is absorbed or released. Think of fire. If you think of fire, it will release heat. And that's a chemical reaction. Okay, and that would be heat being released. Absorbed is a lot rarer. So we'll do some examples of that in class, but there's not one that pops into my head right away. Color change. That was bread. It has mold. That's a color change. Molding is a chemical change. When a gas is produced, so again, think of fire. And this fire, see how smoke is being produced? Another sign of a chemical change. And then a precipitate forms. You do need to know what a precipitate is. A precipitate is when a solid, like this solid, forms from 2 or more aqueous solutions. I like to call it precipitate chunks. Chunk. Okay. Coefficients tell you the number of particles and moles. So I'm going to do the same thing. Now on this one, I'm going to balance this a little bit differently. Instead of drawing all the pictures, I'm just going to count the particles. So I'm going to start with C. And on the left-hand side, I have 1 carbon. I'm going to look at the H's. The H's I have on the left-hand side, get back here, is 4. And the O's I have on the left-hand side is 1. Come here, please. Plus 2 is 3. That's annoying. Maybe if I try it over here. Nope. Okay. Over here, the number of carbons I have, so I'm going to put them in the same order, C, H, and O. The number of carbons I have on the left-hand side. Ooh, that's creepy. Now I'm being haunted by my computer. Carbon, I have 1 carbon. I have 2 hydrogens, and here I have 2 and 1, 3 oxygens. So I'm going to try and balance this as quick as I can. This one has 3 oxygens, that maybe will show up on the screen. So I'm going to balance my hydrogens first. Okay. So if I want 4 hydrogens, I'm going to put a 2 over here. Okay. 2 times 2 gives me 4 hydrogens, and 2 times 2 gives me 2 oxygens. But I have another 2 oxygens, which would be 4 oxygens. Okay. So right now these are all messed up, right? I can't put a number right here that'll balance my oxygens, but I can put a number right here to balance my oxygens. Now I know that's going to mess my stuff up, but tough noogies, man. You have to mess it up to balance equations. So now I have 2 times 1, 2 carbons. I have 6, 2 times 3 is 6, plus 2, I have 8 hydrogens. Okay. Now if I have 8 hydrogens, I have to get 8 hydrogens over here. Oh no, I have to erase it. Look at the pain it causes me. Oh, okay, it doesn't cause me any pain. Okay, so it's not so bad. All right. Oh, I also have to fix my carbons, right? So I have 2 carbons on the left, I need 2 carbons on the right. So 2 carbons here would also give me 4 oxygens, plus 4 oxygens, which would be 8 oxygens. Okay. So now I need to fix my oxygens. From here, I have 2 oxygens. I need to get another 6 from here. 3 times 2 is 6. 2 times 1 is 2. That gives me 8, and I'm balanced. Okay. Now, this tells me I have 2 molecules or 2 particles of CH3OH, 3 particles of O2, 2 particles of CO2, and 4 H2O. Now, what if I had pairs? Do you see how I could have 2 pairs of this would give me 3 pairs of this, would give me 2 pairs of this, would give me 4 pairs of this. Now, we don't count particles in pairs. We don't count them in dozens. We count them in moles. Right? Remember, a mole was 6.02 E23. So if I have 2 moles, or 2 times 6.02 times 10 to the 23rd, I would have 3 halves as much, right? 3 moles of this, and I would have 2 moles of this, and I would have 4 moles, I'm going to put this in here, of water. Okay, so you need to know the coefficients tell you the number of particles and the number of moles. And then for some strange reason, all this writing comes back here. Oh man. So, review chemical reactions, rearrange atoms, and break and form bonds. Chemical reactions have signs like precipitate, heat being released, and more. And we can see these signs. That's creepy. Balancing can be done with pictures or the column method, or even guess and check. Atoms are conserved in reactions, and conservation of matter is the same thing as balancing a reaction. Huh, how about that? Sounds good. See you in class. Toodles.